This conference will now be recorded.
Okay.
So this presentation and the spec are not up on the wiki yet. They're still trying to get some final stuff on the CLA sorted out or find the right copy of it.
Yeah. Let me try to. Yeah.
We will get this on the wiki as soon as we
Okay.
can.
Okay. Hey, hello everyone. Today I'm going to present our new OCP product. That's called the KP2. The 2 means the second generation. For OCP, this KP2 is can support the AMD new generation CPU. This is the our CPU. And for this CPU, I can support the DDR5 memory and the PCIe Gen 5. Also, we design in the BNC with the ASP AST 2600. And for scalable, we define the 2 SKU for this product. One can be for the compute use. Another one is the purpose for design for the AI inference. For the openness, this product can support one OCP magazine for the NICA or HBA card. And also this product can support the OpenRec V2 or V3. I will introduce more later. And for the impact, this form factor is the same as Capri or Tioga Pass. So this product can support the copy shift for the OpenRec V3 candidate. And also we modify the copy for the OpenRec V3. So the form factor is not a big change, but it can support the OpenRec V2 or V3. Okay. Now, what is the difference between the Capri and the Capri 2? Yeah. So for the migration, Capri, the left side is our Capri. We contributed this spec 2 years ago. The next time we also define the 2 SKU. One is the advanced SKU, another one is the ultra SKU. The advanced SKU can support the SATA SSD plus the 2 PCI card. Ultra SKU support the 4 U.2 plus the 1 PCI card. And then this time we thinking about how to improve this product. So we merge the 2 SKUs to be 1 SKU. That's the core, the standard SKUs. And this is a standard SKU. We don't continue to support the SATA SSD, but we keep the U.2 for this product. So the new Capri 2 standard SKU can support 2 PCI card plus the 2 U.2 drives. And also the difference is this Capri 2 can support the OCP V3 magazine card, and the Capri 2 is support the OpenRec OCP V2 magazine card. This is a bigger difference. And also we create another skill can support the GPU cards. That's because we hear many voice from our customers, and they like our product can support double wide GPU card. So that's why we design in this feature in the Capri 2. And but the space is the limiter, so we design in the E1.S for the ultra skill for saving the space. So we will have more space for the PCI card, double wide GPU cards, like this picture to show. Okay. And this is the features for our Capri 2 OCP computing space, and this product can support the V3. And how to support the OpenRec V2 or V3? And that's because we design a PDB board that can convert the 48 VDC to 12. When we support the OpenRec V2, we just remove out this PDB, so that can support the 12 VDC OpenRec V2 ambient. And this product all is the tool list design. So when do the maintenance, doesn't need to have any tools. And also this product support the redfish, and for the ultra skill and can support the double wide GPU card. And this is a more detailed spec. You see there's the two skills, yeah, standard skill and the ultra skills. And the both skill can support OpenRec V2. For the GPU cards, is only support we call the CP2S11 dash U48 Ultra. That's because the GPU card, if we put the GPU card on the OpenRec V2 skill, and the power, the current limiter will not support it yet. That's because the Medusa cable, it cannot support the much power. When we put this into the OpenRec V3, we can get more power from the bus bar. That's because the voltage is changed to 48. So we don't need much current from the Medusa cable. Now for the CPUs, it's support one Genoa CPU, and right now we test the Genoa CPU, and this for the air cooling, it can support the 360 watts CPU at the room temperatures. This is the without the GPU. Yeah, if with the GPUs, it can support the 280 watts GPU cards at the 35 degrees. Yeah. And for the memory, even the Genoa CPU have a 12 channel memory, but we design this product with the 8 channels. And that's because we wanted to keep the capacity in 2OU. Yeah, if we change the DIN slot to 12 in the 2OU, and this is maybe only have the 2 nodes, but we keep the A this slot, we could have 2 OU with the 3 nodes. Okay. Now for the management, we reserve the 1 giga length for the dedicated management port. Now for the IOs, of course, we have the 2 USBs and 1 mini display port for the VGA. This just show you the Capri 2 with the copy shape. So in the 2 OU, total have the 3 slates. We don't change the slab space. So we design 1 bracket for holding this motherboard, like so the motherboard will facing in this bracket, and can install motherboard with this bracket into the slash base. And this is the front views for our standard skills. So there's the 2 UDA2s and 2 low profile PCI cards. Now for the fans, we change the fan to be the high performance fans. That's why we can cooling the high power CPU like 360 watts. And this is the ISO views for the view.
Michael, do you intend to take question now or will take question at the end of your presentation?
Okay. Okay.
It's a question. Like, do you want to take question now or will take question at the end of your presentation?
Sorry. What is
Do you
your
want, yeah, do you want us to ask question now or we ask question at the end of your presentation?
you can ask right now.
Okay, yeah, in this view, right, the front view, so there seems to be a lot of empty space. How do we comply to EMI?
For the EMI, this is a good question. That's because most of the people they use the OCP, they are just only for the internal use. So they don't care about the EMI. This is most of the customers most use from our customer, they say.
I see. Internal use as in internal development use?
Yeah, for the government, there's probably maybe have some problem because they they need the product that's the pass the all EMI testings. So because this is open frame, so for the EMI probably have some issues.
I see. Yeah. Sorry, one more question. Just now you mentioned about this is a Genoa with uh, an 8-channel DDR. Which socket do you use for this design?
You mean the channels?
The socket. I think there's 2 versions of Genoa socket, right?
Yes.
Yeah. Which socket do you use? I think there's a specific 8-channel. Is it that one?
Yeah, this there is the 12 channel, and we only use the 8 channel. And this 8 channel is the recommended by the AMD, and that's because AMD define the 64 cores with the A channels. So we only pick the A channels for the DDR A DDR pins.
I see. So this is a SP5 socket with a 8-channel design. Okay, thank you.
Yes, yes, it's the A channel device. Okay, go next. This is the type views. Yeah, you see in the top views, this is for the 12 VDC. That means that this is for the open rate V2. Bottom one is the 48 VDC, and this is the open rate V3. So the difference is this PDB. We design this PDB to convert the 48 VDC to 12. This just show you the details of the ISO views. This show you all parts for the standard SKU. So of course there is the one duct for the tower. And there is the one two slot PCI risers. Then we use the MCIO cables connected to the motherboards for the PCI lanes. And there is the one UDATURA modules with the backplanes. And also there is the one SSD LED sports. And this design is as the same as the Capri or Yogawa pass. There is the two, and this can support two M.2 PCIe type M.2. So if you like to do the redundancy, or is the redundancy, so there is the two M.2 options for OS.
Michael, sorry, this is Oriol from Summer. On the slide before, you were showing there the differences between the version 2 and the version 3. You were showing that this is following the standard of 48 volts. Do you know if these servers will be able to handle, instead of 48, 51, maybe 54 volts, or it will be too much for the PDB design? Thank you.
Yes. Yeah, of course, we say the 48, but this product can handle the power shift. Normally, the power shift is 50 watt output. So it can support a 51 VDC input.
And what about 54? 54 volts will be too much, or still
54, yes, 54, yes. And we designed this product following the open rate V3 power shift spec. So the power shift spec is defined from, I remember it's 40, 44 or 48, I forgot it, until 54 VDC input. So we can support this range.
Okay, thank you.
Now this is a front view for the Ultra SKUs. So you see the top two PCI slot that can support one SKU card, and also there is the one 4 high length card. This so total have the 3 PCI cards, 2 by 16, 1 by 8. And on the right side, there's the 4 81 data SSD base. This is can support 5 mm or 9 mm E1 data SSD. This
Just time check. Are you getting close to the end of your presentation?
okay. This is ultra skill. You see this space with reserve space. Otherwise, there is the one cable for the GPU. This just show you the view. For the board wise, there is the PCI writable and the one U1 data SSD. You can see it's very easy to move out the modules. For the U1 data SSD, it's very easy to move out the U1 data. For the change the PCI card, it's also very easy. This is the motherboard placement. So you see, there is the 3 by 16 MCIOs, 1 by 8 MCIO connector. So the 4 MCIO connector all for the SSD backplane or riser card. And they use the MCIO cable for linking the PCI signals. And there is the one PCI by 1 connector here. This is another for signal. This is for the riser's power.
Hey, Michael, question. This is Glenn. I'm curious as to why you decided to put all of the baseboard management down on this board instead of going with one of the either the horizontal probably doesn't fit, but maybe even the vertical DCSCM modules in here. It seems like you have a long board just to get a few indicators and some RJ45s out of here. Whereas if you were to cut that board off right at where the OCP neck connector is, you could really reduce the cost of this baseboard and go with a more modular approach that has your, instead of your ID fault LED stuff, that could be a small little board, very cheap, maybe 4 layers wired up, and you could change layers and things for your DCSCM to be different than your motherboard.
Yeah. This is good question. This is because we wanted to keep the form factor as the same last generation, and so the space is limited. So we wanted to have the OCP 3 magazine card. So there is no space for the DCSCM. And if we use the vertical DCSCM, it will impact the PCI cards. Let me see. Please. So there is no space for the vertical DCSCM.
Could you not shift the cards over to the right and put your E1Ss down in that space maybe or something? Just question, something to think about.
Yeah, this is the trade-off. If we use the DCSCM, we may not have a space for. So if we remove the U1 data access, at least the product will no storage. So this trade-off, we thinking about this before, but we decide not to implement the DCS-CM in this. So is that answer your question?
Yep, thank you.
No, this is block diagrams. Yeah.
Yeah, so Michael, are you almost through here? We are a little bit over time.
Yeah. This I will not go details of. And this motherboard is 40 layer designs, and this is top budgets. And top budgets around 1100 watts. So any question for our capability? Hand over to the John.
John, you're on mute.
Oh, sorry about that. So Michael, this will be presented as a specification to OCP, I assume?
Yes.
Do you have a time frame on that?
Yeah, I already present my specification, and for the details engineer spec, I will update it maybe next month or in the beginning of September. And right now, our team is still writing and reviewing the document.
Okay, sounds good. All right, now we have going through our sub-project updates. Bappy, you have a ODSA sub-project update?
I do, but I've got to leave in a minute, so I'll make it a 1-2 line summary if you don't mind.
All right.
I think our big highlights are we've completed a schedule for the global summit, and our work streams are making decent progress. We've got a whole bunch of talks from ARM, Blue Cheetah, Department of Energy, Elian, Intel, Marvell, and Siemens. We've got 3 panels, one on startups, one on building the supply chain with chiplets, and a third one where then I'm in what I think is going to be the first ever where we're going to talk about building the chiplet economy, where we have people actually. I think we're going to put together the first ever public demo of actual chiplets. Hopefully we'll have a booth or a portion of the shop floor in the experience center, and we have a lot of interest in companies building chiplets in demoing something tangible there. And we're organizing a workshop on chiplets with the Department of Energy in mid-August. So that's to help the DOE set research direction on chiplets. It's mainly towards the government audience. We're going to have participants from the Department of Energy and several national labs, the Department of Defense, I think NIST, and a few other government agencies as well. That's it. Thank you.
Okay, good. Sounds good. Alan, you have a HPC sub-project update.
Hi, thanks, John. Yeah, mine's just a verbal one today, but we are actually making quite a lot of progress at the moment. So we've been in concept stage for obviously quite a long time, but now we've put together what we call the wall of compute to mount these high performance compute modules, and we've got the infrastructure. We've had a bunch of thermal design companies help us with with the concept. We're in sort of final refinements of the module itself and making some tweaks to that based on some feedback. And the really good news is we've got a little bit of a research program going with the University of Illinois Urbana-Champaign, where they've got this conformally coated copper approach for cooling, for actually transferring the heat from the silicon and the components on the board into the water. So we're actually going to build a prototype product for that, like a test vehicle for the power delivery and the thermal management of up to the 1.4 kilowatts. And there's a small startup called Load Slammer or Program Analog, and they're building adapters that can actually burn a kilowatt of power, and we're doing that in a footprint of our first HPCM module, which will be an AMD Versal FPGA, a large AMD Versal FPGA. So we'll be able to build the test setup without having to buy $10,000 chips. so that's that. And even better news from a company called Iabra, which is an AI, they're not so much of a startup anymore, but an AI company in the UK. They're known for actually building COVID testers using AI without any reagent mixing. So they've done quite well on the back of that. But now they're setting up what they call a skunkworks AI division of, I can't say the name, but a very large European defense company or UK defense company. There's only a few, so you can probably guess. And they're going to invest in actually helping HPCM become a reality. So that's really fantastic news. We have partaken in the composable memory system work group. So just to re-emphasize, I think I mentioned it before, we're looking at, the technology is really good. Well, the focus of the technology is sustainability and energy-centric computing. Everything we do is focused on that, every action we take. And but the two key drivers that we're working on is CXL enablement, which could be a good low-cost platform for researchers to work and help get CXL enablement, and also hopefully chiplet enablement. And we've made some progress in that area as well. I've been doing a little bit of work with BAPI on that, and hopefully we might be able to get HPCM as a chiplet enablement platform to try and bootstrap this massive task of trying to get to a chiplet industry. And that's the update from me. Thanks.
All right. Thank you, Alan. And you have any questions or comments for Alan? All right. Next up, we have Damien with the OCP NICS subproject update.
Okay, let me share real quick. Okay, can you see my screen?
Yes.
Okay. Yeah, we're going to talk about two things today, thermal test fixture modification and our SI test fixture. So as shared before earlier, that we do have some problem with our thermal test fixture. The proposal direction has been confirmed. We're going to add additional holes to the side of the fixture to solve the problem whereby there's the airflow sensor in this area that actually measured less airflow than the actual airflow being seen when at the NIC, because there's no holes for airflow to escape. So there's kind of concentrate in this area. So we have did additional simulation using the new modification of the holes. Then now we can see like the updated configuration, the AC and QSDDD, they are kind of about the same thermal performance, whereby in the past without the simulation actually show that the QSDDD can actually sustain either a higher temperature or a lower airflow, depending how you read the chart. So this is actually not likely will not be correct in the real system. So so these are simulation information. Then this is the direction we gonna fabricate these new changes and then test it out in real testing. So this is the update for thermal test fixture. The second part is regarding SI test fixture that will present at the IC meeting for the CLB 5.0 contribution. And then as for the CBB, it should have already arrived and waiting for testing. Just a little bit of publicity about next week, or no, actually next week and also next month, OCP NIC monthly meeting. We're gonna discuss about a double wide small form factor. So if there's something interesting to you or something you don't like to see happening, either way, do join us. We would like to hear from the NIC vendor. We would like to hear from the system vendor as well. Okay. That's it for me for this week.
Okay. Any comments on the OCP NIC tracks for Summit?
Regarding the OCP NIC track, I think we have two selection, and then yeah, the time frame looks good.
Okay. Good. Thanks,
Yeah.
Damien. Anybody else have any questions for Damien? All right. Next up, we have Song OEM OAI subproject update.
Yeah, John, I have the verbal update today. So on the expansion module side, right now we have two retimer vendor is helping on the end-to-end SI channel assessment, and the intent to do that is to lock down the pinout on the connector so that it meet the 112 gig requirement. Yeah, and we still continue to updating the spec for the expansion module, and we're still targeting to get it done by Q3 timeframe. And on another thing is that the UBB tray, we are going to produce the mechanical spec for that, so that we're going to have like two configuration. One is with the UBB 2.0, another one is with the AGN spaceport. So the mechanical spec will have these two configuration on that. And this is what I have for today.
All right. Anybody have any OEM OAI questions for Song?
Yes, I do have one. So Song, is UBP 2.0 specification is ready in the wiki?
It's in the OCP database, but we have not updated the wiki link yet. Let me go ahead and do that. We do have the 0.5 version available, and OAM is a 0.7 version. Yeah.
Okay, thanks.
Mhm.
All right. Thank you. Next up, we have the Composable Memory System subproject update. I don't see Manoj online. Did I miss him, or is anybody else here to talk about CMS? Okay, I assume there's no update this month. I know Sean is on a business trip, but I do see Brian here for DCMHS subproject. Brian?
Yeah, sure. Let me share what our update from the public meeting. Can you see what I'm sharing, John?
Yes.
So this is the update from our public meeting from last week. We went over the tracks that we're planning to do for Global Summit. Currently, there's 9 tracks that are approved. You can see them listed here, and they're also available. This presentation is on our wiki if you want to read up on these. We're scheduled for October 19th from 8 to 4. And we'll also have about 4 demos in the Experience Center that aren't listed here. Regarding the MHPM workstream, we will be releasing a new Dino specification that we're calling 1.01. I think the plan for that release is before Friday this week. So just a few more days and we'll get that posted to the wiki. It's mostly just cleanup and incorporation of one of our ECN number ones to correct some E1S locations. So nothing new in that spec other than cleanup. And then we're still working on our new specification for open rack optimized HPMs. These are wider HPMs. Currently, we were hoping to release that the end of the month, but I think we're probably a month behind. I think the trend is probably likely end of August. So that one's still coming. Regarding our next CRPS spec, we have 1.01 RC2, very similar to MDino spec. It's mostly a lot of cleanup, some additional features. We're in the process of finalizing that spec, and I'm hoping that the team gets that posted to our wiki within a week. So 2 specs just on the verge of getting posted, and we'll send out an email when both of those are up. We did post an updated PESTI specification. We're calling it 1.1 RC5. You can see some of the changes. There was cleanup, some simplification, some tolerance changes. That is available on our wiki now, and we did send out an email to our email reflector for folks to go and download that. After the call, you can visit our wiki and also grab that if you haven't seen it. And then on our shared infrastructure spec, it's kind of similar position as our new HPM spec, where we had hoped to have something the end of July, but I think it is also on track for something more closer to the end of August. Any questions on that?
Are we doing anything officially with other SCM form factors or Edge HPMs?
Okay. There's sort of 3 parts to that question. Regarding SCM, we are working with the SCM team on the new 1.1 spec, which if I'm not, or sorry, 2.1 spec, if I'm not mistaken, that spec is up on their wiki. We are looking at a smaller SCM. I gave an update a month ago that NVIDIA joined DCMHS, and we're looking at working with the SCM team on something from NVIDIA's MGX architecture, which is more similar to an internal vertical SCM. That is not final yet, but it's on our list of things to go look at. So we are working with the SCM community on that. I think you heard Damien ask about UBB 2.0. We are interested in figuring out how to incorporate UBB 2.0 into our shared infrastructure workstream, which is part of the reason why it's taking longer to release our new spec. So we're looking at that. And then the final thing is we are looking at doing edge systems as part of DCMHS. I don't know. We have to work through some of the legalities. So would edge systems be under DCMHS, or would it be a sister group of MHS? MHS was really targeted at data center, but opening it up to edge, brings in potential new CLA partners. So I think that's the part that we're currently looking at. But to answer your question, yes, we are looking at edge. And if I go back to the global summit tracks, I think we have 1, if not 2 presentations where we will be going into more details on edge. I'm trying to scan through these right now to see if it pops out at me. Want to say it's the design with DCMHS, the 4182 track, with Dirk from Intel presenting. But we are looking at incorporating Edge.
All right, thank you. Anyone else have any questions for Brian? All right, thank you, Brian.
Yeah.
Then we have workstream updates. Stantature was going to do a SIOV R2 update. I don't see him online. Did I miss you, Tom? Okay, well, it looks like he had some conflict and wasn't able to join us here. I also don't see Mohammed online for external PCI connectivity. Did I miss him, or does anybody else have any updates on PCI connectivity? Okay. We normally do cover the hardware management, but Queen normally isn't able to join us. She does have a status update online that I forgot to pull up and look at. Let's see what updates we have there. Last update there is from 5/16, so it looks like we don't have an update on that this month. That leaves us to a final discussion. There have been some emails going back and forth on collaboration with the Immersion Project for ORV3 power infrastructure. We have Kevin Garrow and Oriol Chavellini. If you want to introduce yourselves and kind of give us a quick update of what you're looking at.
This is Kevin Jarrow. Basically, what we're looking at is the power infrastructure and immersion. And one of the items that has come up is the input voltage to the server. ORV3 is selected a 51 volt input. But one of the problems that we're having is when you start to increase the density and end up with 50 kilowatts, or just for an example, the bus bar and the connectors are being pushed, especially in air, and even in fluid, because it doesn't matter. You're still pushing them to get the power through there, and the voltage drop, as you probably all know, is I squared R. So if you go to a 54 volt input, and I believe that the spec for servers allows it, but if you look at ORV3, everybody is doing 51 volts and doesn't allow a 54 volt, or I shouldn't say doesn't allow. They typically don't do 54 volts, but there's a 10.8% difference in the voltage drop, which translates to thermals in the connector and the bus bar. And especially when you start doing 50 kilowatts and up, that starts to matter. So I'm a power guy, and when I look at that, I say, oh, 54 volts makes a lot of sense. I know why ORV3 did 51 volts, because if you use just a 4-to-1 DC to DC converter, it's a little bit more efficient than if you use a 5-to-1. But when you start looking at the voltage drops in the connectors and the bus bars, 54 volts makes a lot of sense. Anyway, it's an item that I wanted to bring up and see if there's some views on it. I don't believe people are restricting 51 volts or 54 volts, but by definition, ORV3 is 51. And I just wanted to bring it up because when you start doing 50 kilowatts and up, which a lot of us are looking at, it does make sense to go to 54 volts. And you can get pretty close to the same efficiency if you go that direction. I just wondered if anybody has been working on that or had thought of that, or are they sticking with the 51 because it is the ORV3 spec, or any thoughts?
Indirectly related, Kevin. I'm on the, this is Alan. I think you've joined.
Hey, Alan.
Hi. One of the things I observed is the really efficient down converters from 48 or 50, whatever it is, down to the 12 volts, the most efficient ones are uncontrolled. So therefore, they literally just divide by 4.
Correct.
And the spec is between 40 volts and 60 volts, I believe. I would like the SSD, so that all of these little media devices that are powered by 12 volts, they have a plus and minus 10% going into them. So you have to build a regulated, inefficient down converter. So I was wondering but if you look inside these SSDs, the power devices tend to have an input voltage up to 16 volts. And so in reality, a 4-to-1 step down most efficient would be the best approach if we could get the media industry, the SSDs, etc., to actually loosen the 10% tolerance on their 12 volts. That would be a massive industry benefit. Does that make sense?
I understand what you're saying. Yes, it's similar to what I'm talking about, but I'm talking more from the.
Yeah, right, exactly. No, I agree. You're talking about all the drops, and as you know, what we're trying to do, we're trying to reduce that drop. So our solution actually deals with what you're talking about. I think to a certain extent.
It does. It does. Similar. It's the same type of reasoning. I mean, to me, what has happened is when the ORV3 spec initially came out and the power supply spec came out, they selected 51 volts because of that 4-to-1 non-isolated DC to DC.
Right.
But they were talking about 15 kilowatts, and in that the clip connector and the bus bar were just fine. But when you start going to 50 kilowatts or more, then now the clip connector starts getting in trouble, and the bus bar has to be increased dramatically. And if you go above 50 kilowatts in air, the bus bar has trouble, and even the clip, you start getting into trouble. So that's where I'm coming from. That's, and I think what you're talking about, if you did that, then the 4-to-1 would work just fine from 54 volts down. It would allow it. But you can actually get a 5-to-1 non-isolated as well. It's just that that's not the direction people have gone.
Right. I don't know. I mean, that's an industry-wide decision that could instantly improve efficiency, but it would need the whole industry to accept the plus or minus 15% instead of plus or minus 10 or whatever it is.
I understand what you're saying, and that's sort of why I wanted to bring it up. My discussion in this, to start some people thinking and talking. I know that presently the spec is what it is, but there are also, I mean, in the past, we know Google presented a 48 volt system / 54 volt system to the OCP, so it's out there, and it's what the servers are designed to do, and if they design it with the 51 volt in mind, typically 54 volts doesn't work because then you need 10% higher than that, and so that DC to DC won't handle it. So you have to, I mean, you can do this, but as you said, we need to have some discussions with in the market and in the industry, because it's a different purpose. When you're starting to look at 50 kilowatts or 75 kilowatts or 100 kilowatts, that's different than if you're looking at 15 kilowatts. So efficiency is one thing, but then voltage drop becomes another, which translates to efficiency. So it's a rather complex discussion that I just wanted to start.
Yeah,
thank you,
but it's a
Kevin.
discussion that comes across the rack and power and the server, including HPC and your cooling environments. So it's definitely cross projects. So it doesn't have a clean home in one place. It needs to be talked about across different projects.
Yes, agreed. That's why I wanted to bring it up in your team, and we're talking about it in the Power for Immersion, and the majority of the people in Power for Immersion, because we're talking power, tend to agree that 54 is just fine. Let's go. Well, but it's all dependent upon what the server will allow. So
Also from sorry, this is Oriol from Summer as well. So also from the tank perspective, at this matter, as Kevin was suggesting, we are tackling at 50 kilowatts, 100 kilowatts in one single tank. So maybe looking on the air racks, you may have different servers which require different configurations, different voltages. So you may have different air racks. Maybe you can have a power shelf that delivers 51 and another power shelf that delivers 54 on two different air racks, and still you can manage it in the same data center. But at immersion, where we speak about density and having a lot of compute in the same tank, you will need to have probably different brands and models of servers that need to collide on the same specification and the same requirement. So if we need to run 100 kilowatts in the same tank and there will be different brands, all of them need to go on the same voltage, or we will have these discrepancies. So that's also an important topic when we speak in the immersion tanks in the power distribution, just because of the density that we are looking at.
Yeah, definitely need to have future discussions. We are actually 4 minutes over, so
okay.
thank you, Kevin, and thank you, Oriol, for bringing
Thank
this
you.
up. And we'll leave it as a work stream update every month to see if anybody's on and wants to discuss it. And if nobody's on, we won't discuss it, but we'll leave it on the agenda here just to remind ourselves.
Thank you, John.
Thank you much.
All right. Well, thank you everyone for joining. Apologize for being a few minutes over. It always seems like we go over even when we don't think we have a full agenda. Time always expands to fill the space. Thank you everyone, and we'll talk to everyone next month. Thank you.
Thank you. Bye-bye.
Bye.